Hello, everyone, and welcome to my tech talk about IPFS, a decentralized solution for the modern internet. But first, let me introduce myself. My name is Felipe, and I'm very interested in decentralized technologies and how they can be used to tackle many of the challenges we face when trying to communicate and share information online. And that's exactly why I want to talk about the IPFS today. So first, we'll go through an introduction of IPFS. Then we'll see some of the real-world projects that are using this technology. And then later, I'll introduce some tools that you can use to get started with IPFS. Then we're getting into a demo where I'll show some of these tools in practice. And then finally, I'll make a few comments on the current state of the technology and what to expect for the future. Okay, so what is IPFS? IPFS stands for InterPlanetary File System. And it's not just a funny name. That is the actual long-term goal of the project. It was created by Juan Benet, and it was first released in February of 2015. And a straightforward definition of IPFS is that it's a peer-to-peer network for sharing data in a distributed way. Now let's see some examples to understand what that looks like. First, let's look at how the conventional internet looks like. A user sends a request to the internet, but more specifically, the request is addressed to a server. And that request boils down to, please give me whatever file is living in this address. In this case, example.com/file. That request travels around the internet, sometimes around the world, and hits the server. The server does what it needs to do and sends the file back to the user. If this transaction goes well, the user receives the file they were expecting. But what if it doesn't go well? Let's say the user sends a request, it reaches the server, but the server doesn't have the file for the request. Maybe the file doesn't exist anymore, or maybe it never did. The server is the only source of data, so the user's out of luck. There's no way for them to know where the file is, could be lost forever at this point. Another situation that can happen is the server sends back a file, but it's not the file the user was looking for. Could the user have made a mistake, or maybe the server? Well, either way, the user's out of luck once again. Well, how about this one? The user makes a request, but there's no server on the other end. Maybe the server is down, or maybe the government is censoring parts of the internet. And here goes one last example. Can you tell what's the problem here? Everything's looking fine. The user got the file they wanted, or did they? The problem here is that the server was compromised, and the real file was replaced with a malicious one. The user doesn't realize the switch and installs the file in their work computer. Next thing they know, their company is paying millions of dollars in ransom money to get their data back from the hands of a criminal organization. Now things have gone horribly wrong. So it looks like there are many issues with the way we currently do things. And we can boil down those issues into two concepts: client-server model and location addressing. And we're going to explain these two briefly. Client-server model is the idea that multiple clients must talk to a central server. So the server is the single source of truth and the single point of failure at the same time. And location addressing is the idea that the user makes a request to a location, in that case a server, and in hopes that it contains what they want. So what's the alternative? What IPFS does is, instead of doing a client-server model, it implements a peer-to-peer network. So in this model, peers act both as client and server between each other. So communication is much more resilient. And instead of the user making a request to a location, IPFS does content addressing. The user can ask for a specific file they want by using a hash, which is sort of an identity that is unique for each file. The user makes a request using the hash, and that request gets fulfilled by other peers in the network who happen to have the file or parts of it. The user doesn't have to know where to look for it. The network can figure that out by itself. But if any peer can fulfill a request, how can I trust that they're sending me the correct file? We saw before that you can't always trust what a server sends you. So how can I trust random people? The thing is, there's actually no need to trust anybody. Once you get your file, you can recalculate the file's hash and check if it matches with the one used to send the request. If they match, you have the correct file. There's no way for a peer to trick you into downloading something you didn't ask for. Well, unless they're exploiting some sorts of bugs in IPFS, but that's a whole other topic. Now, some people hear about IPFS and say, I've seen this tech before. It's called BitTorrent. Now, IPFS and BitTorrent may be similar, but they have some very fundamental differences. BitTorrent has been around for longer, and the user base is much larger than IPFS's. BitTorrent also does peer-to-peer networking and content addressing through what's known as magnet links. So why not just stick with BitTorrent and forget about IPFS? Well, let me show you one important difference. For example, let's say there are 3 different folders being shared through BitTorrent. And each folder has 3 photos. And we can see here, some of these photos appear in different folders, the same photo. So it would make sense to have all this data connected somehow, right? So that if a peer has downloaded the first folder, for example, they could help someone else to download the second folder because some photos are repeated. Unfortunately, the way BitTorrent currently works is to treat each folder as its own independent collection data. So the data is not connected between at all. IPFS, on the other hand, puts all data in the same network. So you can piece together a folder from peers who have other folders. This is just one of the main reasons why IPFS is gaining ground in the world of peer-to-peer networking. Now that we know why people would want to use IPFS, let's take a look at some of the interesting apps and services that are using it right now. First one is Decentralized. This is a virtual world where users can play and create their own games and activities. And all the visual assets like 3D models and textures are stored and distributed by the players through IPFS. And the whole thing runs on top of decentralized technologies. So their slogan, owned by its users, is not an overstatement. Next up is Filecoin, which is a cryptocurrency that is actually independent from IPFS, but interoperates with it. And the motivation behind Filecoin is to promote data persistence in the network by letting users rent their storage capacity in exchange for cryptocurrency. So in a way, it creates an alternative to conventional cloud storage services like Google Drive, iCloud, and so on. Another interesting project is IPVC, the Interplanetary Version Control. It's a version control system very similar to Git, but your commits get sent to the IPFS. So you can have a remote repository that is decentralized, which is pretty interesting. There's also an open source messaging app called Birdie, and it works in a very unique way. Basically, it leverages the power of IPFS, and it allows users to communicate in a peer-to-peer fashion. So there's no server coordinating everything behind the scenes, and that makes conversations much more private. It's still in early development though, but the developers welcome people who want to help and give feedback. So if you're interested, give it a shot. I also want to mention pinning services such as Pinata. Typically, when you first set up your own IPFS node, you'll be connected to a small number of peers. So any file that you add to the network won't be available to many people straight away. And what these pinning services do is they let you upload your files to their IPFS nodes, which are connected to a huge number of peers. So your files become highly available to others almost immediately. It's pretty useful stuff. And there are many other apps and services leveraging IPFS. There are databases like OrbitDB. There are cloud hosting services like Textile. And you can even use NPM on IPFS to retrieve packages for your projects. I recommend taking a look at the awesome IPFS repository on GitHub. If you're thinking about using IPFS on your projects, there's a good chance you can find a tool library there to make your life easier. Now I want to show you some tools you can use to set up your own node and start using IPFS. And by the way, I'm going to be using some of these tools in the demo that's coming up next. First, there's Go IPFS. This is the reference implementation of IPFS, and it's written in Go. You can use it to run your own node and start sharing files on a network. The caveat here is that it's a command line tool, but there are graphical interfaces that can run on top of it. And I'll get to them in a minute. Similar to the previous one, there is JS IPFS, which is another official implementation, but it's written in JavaScript. For all intents and purposes, both have pretty much the same functionality. Now to the graphical interfaces, there's IPFS Desktop, which provides a GUI on top of Go IPFS. And if you download it and install it, it will also install Go IPFS for you if you don't already have it. So it's pretty convenient. Alternatively, you could get the extension for Firefox and Chromium-based browsers called IPFS Companion. It provides pretty much the same functionality as IPFS Desktop. Another option is to use the Brave browser. It has built-in support for IPFS, which basically means you get most of the perks from the other tools right out of the box. Now I want to demonstrate how you can use some of these tools to start using IPFS. First of all, let's go to ipfs.io. I'll go ahead and click on Get Started. And here we see some of the options we can choose from. For this demo, I'll be showcasing the command line interface, and later I'll also install and take a look at the IPFS Companion for Google Chrome. So let's go ahead and click on Install the IPFS CLI. It takes us to the IPFS documentation, and here we have a quick start guide. And there's this prerequisite for following the guide. We need to install Go IPFS. So let's click here and see the instructions. If I scroll down a bit, we can see separate instructions for different operating systems. I'm on a Mac OS right now, so let's click on Mac. So it seems we need to install the Go IPFS binary. So I'm going to copy this line here and paste it in my terminal. Now make sure you're downloading the correct file for your process architecture. In my case, I'm using Apple Silicon, so I'm going to change AMD to ARM. And then you can just hit enter and wait for the download to finish. I actually already have the file here, so I'm not going to download it again. After the download is finished, we should be able to see a tar file here. So the next step is to extract it. So let's run tar-xvzf, the name of the file. And the contents was extracted to a directory named Go IPFS. So let's cd into it. And we can take a look at the contents. And we see there's the IPFS binary and a README file. And the README file explains how to install the binary. It basically says that you need to move it into user local bin. So that's what I'm going to do right now. Okay, now that we moved it to user local bin, if you have this path in your terminal path, you should be able to run IPFS like this. Okay, so we have it installed. So the first step to run IPFS is to write IPFS init. This creates a directory named .ipfs in the user's home. This is where all IPFS settings and data will be stored. So now that we have initialized it, let's try running this command here. IPFS cat, and then this long hash. We can just copy and paste it in the terminal. And we get some text. So by default, when you run IPFS cat, it prints the file's content to the terminal. Of course, you can pipe the output to a file and have a file with the contents. So let me try doing that. And if we check the contents of this file, okay, we have the text, same text. So now that it seems it's working fine, let's try retrieving another file. This time I'm going to try to retrieve an image. Okay, if I run this, we get an error. So what's happening here is that we're still not connected to other peers in the network. the text file we just got before was actually a local copy that we already had it when we run IPFS IPFS init. So to actually connect to the network, we need to run the IPFS daemon. So I'm going to go ahead and do that on a separate terminal. Just going to open a new window here and run IPFS daemon. Now we're connected to other people, and we should be able to retrieve the image from before. So let's try running it again. Okay, looks like we got it. Let's see. Yeah, here it is. Okay, so now we're able to get some files. How about we try uploading some files? I'm going to actually try to re-upload the same image I just downloaded. So I can just do IPFS, add, and the picture. And we get this hash here that starts with a Q. Now I want you to pay attention that this hash and the hash that I used to get the image, they're the same hash. In IPFS, every file has its own unique hash. So in the end, we're not really re-uploading this file. It already exists in the network. So let's try adding another file. Let's try adding another image. So I'm going to go back a folder. Here I'm going to do IPFS add my images cat JPEG. And here we get another hash. Now, the thing is, if I try to download the image from here, I'm just going to grab my local copy of it. So we need to check if it's actually propagating in the network. And we can do that by using a gateway. So a gateway is just a node, IPFS node, that you can access from the browser. So, and one famous gateway is just the official website, IPFS.io. So if I grab this hash here, and type IPFS.io/IPFS/ and the hash, and hit enter, we get the image. So this is proof that our image is in the IPFS network. We just grabbed it from another node. And we can do the same thing for folders. So let me show you how you can do that. You can do IPFS add, and you do -r to recursively add all the contents in the folder, and then the name of the folder. And here we get many hashes, one for each image, and a final hash for the actual folder. So if we grab this hash and we paste it, we send it to the gateway, we get the folder with the images. I can just check here. I'm going to click one of the images. Yeah. Another thing that you can do is not hosting just simple files like images. You can host an actual static website if you want. So I'm going to show you this simple website. We just have an HTML file, JavaScript, some CSS. The website is very simple. There's just a button that you click and change its color. So how can we host this website on IPFS? Well, we can do basically the same thing we did for the images. We can just say IPFS add -r and the folder. We get a bunch of hashes for each file and the final hash for the actual folder. And if we visit the gateway again with the new hash, the website loads just fine. Now, the whole point of running your own node is that you can download and upload to the network all by yourself. So using a gateway for everything doesn't make much sense. I want to download, I want to see websites using my local node, right? So how can we do that? Do we have to download the website in the terminal and then open it in the browser? Well, you could do that, but there's a better approach. Let's install the IPFS companion extension. Now, this extension basically makes a bridge between your node running on the terminal and your browser. So here we have it installed. We can actually click on status to check on our node. And here we see all sorts of information about our node. But more importantly, now that we have the extension installed, we can access IPFS hashes directly from the browser. So let's try visiting the hash for the website that we just uploaded. Just going to grab the hash here. And to use your own local node, you can type IPFS : and the hash. And there we go. We're accessing the website from our own local node. And now another interesting thing about this extension is now that we have it installed, even if we try to visit a gateway like IPFS.io, it redirects the request to our own local node. So this is just one of the features that you get from installing the extension. And these are just some of the things that you can start doing with IPFS straight away if you use these tools. Okay, so now that we have seen IPFS in action, I want to mention a few things about the state of IPFS. In the beginning of the presentation, I said that IPFS is a peer-to-peer network, but it's actually much more than that. Currently, there's a whole ecosystem of protocols being developed in conjunction with IPFS. We have barely scratched the surface today. There's stuff like IPNS, which is the IPFS equivalent of a DNS server. There's IPLD, which is a protocol that allows interoperation between other decentralized protocols. And we could go on and on for days just talking about the science and technology behind these things. Considering how much progress developers have made over such a short amount of time, is IPFS ready to take over the world and change the way we use the internet? The answer is no, but give it a few more years. One big issue with IPFS right now is that content discovery tends to be slow. In the demo, things seem to work smoothly, but that's because in the interest of time, I was using a pinning service behind the scenes to make files more readily available. In my personal experience, it can take up to 20 minutes from the time I add a file to my local node to the time I can access it via gateway, if I'm not using a pinning service. But the good news is interest in technology is growing, and as more developers and businesses and people in general get involved, progress becomes much faster. I mean, let's give the IPFS people some credit. Interplanetary software isn't built in a day. With that in mind, I want to leave you with this quote from Juan Benet, the creator of IPFS. He said, "Design things for interplanetary scale, and you do very well on Earth." And they're doing very well. And that's it from me. Thank you for taking the time to learn more about the wonderful world of IPFS. If you want to get in touch, feel free to contact me. Thank you very much.